Hello student, I am Dr. Ajay Kumar Sinha, Professor of Chemistry. Today I am going to discuss nucleophiles and electrophiles. Last class I have discussed isomerism, a structural isomerism, and I have also discussed stereoisomerism, and after that I have discussed fission of a covalent bond. Fission of a covalent bond I have discussed means homolytic cleavage and heterolytic cleavage. Now I am going to discuss nucleophiles and electrophiles. All these terms are used in organic reaction mechanism. Yesterday also I discussed about reaction mechanism. And now I am starting nucleophiles and electrophiles. A reagent that brings an electron pair is called a nucleophile. Nu, capital N, small u, that is the abbreviation Nu, nucleophile shortcut we are telling Nu, and a pair of electron. A pair of electron will be there. Nu and 2 point means indicating a pair of electron. Then a reagent that brings an electron pair is called a nucleophile. Nu. Nucleus seeking and the reaction is then called nucleophiles. Okay, Nu, that is a nucleus seeking and the reaction is then called nucleophilic reaction. Nucleophilic reaction. Nu means nucleus seeking. Nu means nucleus seeking. Nu and one pair of electron, that is the indication symbol for nucleophile. Then nucleophile, that is the nucleus seeking. This is called nucleus seeking, means positive charge it is seeking, and the reaction is then called nucleophilic reaction. A reagent that takes away an electron pair is called electrophile. That is a reverse way. A reagent that takes away an electron pair from nucleophile, that is called electrophile. Means electrophile is positively charged, E1 plus. E1 plus means it wants electron, and nucleophile gives electron a pair of electron. Then a reagent that takes away an electron pair is called electrophile. That is the E plus, capital E1 plus. That is the electron seeking. Also called electrophile means electron seeking, and nucleophile means nucleus seeking. Nucleus. This is a difference. Then electrophile E plus means electron seeking, and the reaction is called electrophilic reaction. During a polar organic reaction, a nucleophile attacks an electrophile center of the substrate, which is that specific atom or part of the electrophile that is electron deficient. Similarly, the electrophiles attacks at nucleophilic center, which is the electron-rich center of the substrate. Again, I am telling you, they are very, very important point. During a polar organic reaction, polar means charged. During a polar organic reaction, a nucleophile attacks an electrophile center, because nucleus has electron and electrophile wants electron, requires electron, because that is the positive. Then a nucleophile attacks an electrophile center of the substrate, which is that a specific atom or part of the electrophile that is electron deficient. That's why nucleophile attacks there, that center. Similarly, reverse way, the electrophile attacks at nucleophile center, which is the electron rich center of the substrate. Thus, the electrophiles receives electron pair from nucleophile when the two undergo bonding interaction. A curved arrow, last class I told you, a curved arrow notation is used to show the movement of an electron pair from the nucleophile to the electrophile. Okay, curved arrow notation. Already last class I have discussed, and also I sent these things, diagram also in the last video. Some examples of nucleophiles are the negatively charged ions. Always nucleophile means negatively charged. Okay. Some examples of nucleophiles are the negatively charged ions with lone pair of electron. If negative charge is not there, then at least lone pair of electron should be there, such as hydroxide, OH, 1 minus is there, then it is used as nucleophile. Cyanide, NC, 1 minus. Minus charge is there, means it can donate a pair of electron. Then this is the again example of nucleophile. And carbanion, that is the R3C, 1 pair of electron is there, that is the negative charge is there. R3C, negative charge, having two lone pair of one pair of electron. Then that is the carbanion. This is the also example of nucleophile. Means all negatively charged ion, or you can say atoms having lone pair of electron, all are nucleophile, which can donate the electron. Neutral molecules such as H2O, no charge but 2 pair of electron is there. H2O has 2 lone pair of electron. Then this is the neutral. R3N, 1 pair of electron is there with nitrogen, R3N. R2NH, N has 1 lone pair of electron. Then these are the examples of neutral molecules which behave as a nucleophile. These neutral molecules can also act as nucleophiles due to the presence of lone pair of electrons. Examples of electrophiles: all positive species are electrophiles. Examples of electrophiles include carb-cation or carbocation, you can tell. That is the plus CH3 on C1 plus is there, means it requires a electron. Then carb-cation, all carb-cations are having positive charge, CH3 like a methyl group, CH3 1 positive charge. This is actually electrophile, E plus. And neutral molecules having functional group like carbonyl group. Functional groups like carbonyl group, CO, COO, and now 2 valence bond is there. Then or alkyl, you can say alkyl halide, R3CX, where X is a halogen atom. The carbon atom in carbocation has a sextet configuration, hence it is a electron deficient. Wherever carbon has 6 electron, then they want 8 electron, That's why they seek electron, they want electron, hence behaves as a electron deficient, or also you can tell electrophile. Then this I told you, carbonyl group or alkyl halide, that is the R3CX, where X is a halogen atom. The carbon atom in carbocation has sextet configuration, hence it is a electron deficient and can receive a pair of electrons from the nucleophile. In neutral molecules such as alkyl halides, due to polar of the CX, in that CX, X is a electronegative, X is chlorine, maybe chlorine, bromine, iodine. Okay, fluorine, chlorine, bromine, iodine. Then this in neutral molecules such as alkyl halides, due to polarity of CX CX bond, okay, polarity of CX bond, a partial positive charge is generated on carbon and X gets negative charge. Partial positive charge is generated on the carbon atom, and hence the carbon atom becomes an electrophilic center at which nucleophile can attack. Okay, now few questions I am telling you that can be asked in the medical exam and IIT examination, that you should know. This is for actually question is there, has been already asked, but now I am telling you that question, reading the question, and you can easily answer. Okay, in general examination also it is asked. Now some question is given and you have to answer. Question I am telling you, using curved arrow notation, show the formation of reactive intermediates when the following covalent bonds undergo electrolytic cleavage. Okay, they have given 3 questions. Again I am telling you, using curved arrow notation, show the formation of reactive intermediates when the following covalent bonds undergo heterolytic cleavage. Means anyone will take electron. That you have to recognize. Okay. First is the they have given compound, that is the CH3 SCH3. Second is CH3 cyanide, and next question is CH3 copper. Then now we have to recognize intermediates when the following covalent bonds undergo heterolytic cleavage. Okay, now we have to find out. Then reactive intermediates, how will you find out? It is very easy. First question is given that CH3 SCH3, then this CH3 and between CH3 and SCH3 bond is there. Then now this shared pair of electron CH3 SCH3 means bond is there between carbon and sulfur. That bond will break, and who will take this electron? Then electronegative atom. Then in comparison to carbon and sulfur, who is more electronegative? Then sulfur is more electronegative. Hence this both electron of the broken bond will be taken by sulfur, and it will form it will form carbocation, and it will form other SCH3. S will take electron. Okay, and carbon will give the electron. Hence, C will get plus charge and sulfur will get SCH3, that sulfur will get negative charge. Here you should know that highest electronegative element in whole periodic table is fluorine. After that, oxygen. Third is nitrogen. And fourth is chlorine. After that, bromine, then iodine. This you have to remember. Top is the fluorine, second is the oxygen, third is the nitrogen, fourth is the chlorine, fifth is the bromine, sixth is the iodine. Then sulfur automatically, in comparison to the carbon, sulfur with oxygen group only, that is more reactive, more electronegative. Now another B, question B, part B, that is the CH3CN whole 2. Here again you can see cyanide, that group will take the electron. Okay, then Cn will get electron. C will take the bond will break, CH3 and Cn bond will break, and that bond will be taken because nitrogen is there with Cn. Due to that, it is taking the electron, and CH3 and Cn bond, between that two bond will break, and one pair of electron that will be taken by the Cn. Cn will take 2 electron, that is the negatively charged, and CH3 will get positive charge. Okay. Now third now you can see third question is that CH3Cu. Then you know that copper can donate the electron. Okay, copper can donate it can oxidize, it can lose the electron. Then that copper and CH3 is there, then CH3 will take the electron. Carbon of the CH3 will take the electron of this bond. CH3 and Cu bond is there, and that bond copper will lose. Oxidation will take place. You know that it can donate. It has natural tendency. All metal has natural tendency to lose the electron. Then this bond will be, when bond will break, then both electron, that is the one pair of electron will be taken by copper. Hence, copper will become, both electron will be taken by carbon CH3, and CH3 will become negative and copper will become positive. Now another question I am telling you, which again will be maybe asked in your examination, that is I am telling you question, I am reading the question. Giving justification, categorize the following molecules or ions as a nucleophile or electrophile. They have given these things, some molecules they have given. You have to tell which one is electrophile and which one is nucleophile with your justification. Then now I am talking about first I am telling about the molecules. HS minus, second is BF3, third is C2H5O 1 minus, fourth is CH3 whole 3 N, 2 electrons they have given with a lone pair of electron, nitrogen. Next is Cl minus, and again next is CH3 1 plus, and next is NH2 1 minus, and last is NO2 plus. Means you have to tell out of this which one is a nucleophile and which one is electrophile. Okay. Actually, Cl plus is there, not Cl minus. Cl plus is there. Then now I am making in a two group out of this which are nucleophile and which are electrophile. Then out of this nucleophile, in nucleophile categories, HS minus is there, then obviously it is the nucleophile. Minus means nucleophile or a species having lone pair, that is also nucleophile because it can donate electron. Then in the categories of nucleophile, it will become HS minus, C2H5O minus, CH3 whole 2 N. One lone pair of electron is there. Negative charge is not there, but CH3 whole 3 N, and one pair of electron is there. That is also coming under, that's why it is coming under the nucleophile. Next is NH2 1 minus. Obviously it will be nucleophile. These species have unshared pair of electrons which can be donated and shared with an electrophile. Now another category is electrophile. Then now what is remaining? All will come under the electrophile. Then under the electrophile it will come Cl1 positive. Cl1 positive because positive charge is there. And after that CH3C, one positive charge is there. CH3 C bond, C has positive charge, and after that double bond oxygen is there. Then obviously because carbon has positive charge, then that center is the electrophiles. NO2 plus, that is again electrophile. These reactive sites of this species I am talking about, electrophiles, reactive sites have only 6 valence electrons everywhere. Whatever positive charge is there, that atom has only 6 electrons. Reactive sites have only 6 valence electrons, can accept electron pair from a nucleophile. That's why these are electrophile. And one more question I am telling you, which may be asked in your examination, competitive examination. Identify electrophilic center. Identify electrophilic center in the following questions. I am telling you molecules. CH3CH double O bond, oxygen. CH3CHO bond is there. Then you know that C and O double bond is there. Second is CH3CN. And third is CH3IE. You have to identify electrophilic center. Means that atom should have positive charge that can accept electron. That center you have to find out. Identify electrophilic center in the following molecules. Then first is CH3CHO. Then here just you can think that CO is there, CH3CHO. Then oxygen is electronegative. Oxygen is electronegative atom. Then it will take electron. From where it will take electron? Then C and oxygen double bond is there. Then from that, if bond will break, oxygen will take electron. Means oxygen will be negative, then carbon will be positive. Okay, then carbon will be the electrophilic center. Carbon will be electrophilic center because oxygen is attached there. Oxygen will take the electron. Then obviously carbon will be positive. Another question is that CH3CN. CH3CN. Now here you can see C and N. Triple bond. Nitrogen is electronegative. More electronegative than carbon. Then here what will happen? That nitrogen will take the electron if a bond breaks. Then here carbon will be, when any can say electronegative with will carbon will be positive. Carbon will be positive and nitrogen and the other electronegative atom will be negative only. Then here again carbon will be electrophilic center. And because carbon lacks electron, that's why electrophilic center. And last is CH3I. CH3I. Then here again I is the electronegative. Then carbon will be electropositive. Okay. Then carbon will be electrophilic center. Then here you have to give some mark on the electrophilic center. Some star like that you can put on the carbon, which is all carbon what I told here all are electrophilic center. Then you put one star on the head of carbon. Okay. On carbon you put one star. That's enough. Then starred carbon atoms are electrophilic center as they will have partial positive charge due to polarity of the bond. If electronegative is negative charge, then obviously carbon will be positive charge. Then this I have discussed some questions. Now I am going to tell electrons movement in organic reaction. During organic reaction, electron will move. Electron will move. Then now in which direction it will move, towards which atom it will move, towards which group it will move, that you should know. Then first I am telling you, now I am discussing that point only, electron movement in organic reaction. During organic reaction, movement of electrons. The movement of electrons in organic reaction can be shown by a curved arrow. Always by curved arrow you can show the curved arrow. Already I have told you that you have to use when you want to show the movement of electron. Then direction of curve will be where it is going, in that way. Then curved arrow notation is good for showing the electron movement. It shows how change in bonding occur due to electronic redistribution during the reaction. To show the change in position of a pair of electrons, curved arrow starts from the point from where an electron pair is shifted and it ends at a location to which the pair of electron may move. Okay. From to means from where it is electron is going, from where it is going and where it is going, from and to. Okay. Then easily that if bond breaks, then it will go somewhere, either for left it will go or right it will go, left atom or right atom. Then in that direction, from it will start from there and arrow will be towards where it is going. Okay. Then suppose pi bond was there, then it will break. It will from a pi bond to adjacent bond position it will go. Suppose after that single bond was there, adjacent bond was single bond, and pi bond is breaking, double bond is becoming single, then that electron will shift to the from double bond was there, one bond is breaking, pi bond, then that bond will go to the adjacent bond, which was single, there it may go. Then direction will be from pi bonds to single bond. Okay, curved, arrow is curved. Now, and also you can tell if suppose it is not going to bond, it is going to atom only, then you can show it by from the pi bond, from the pi bond to atom on the head of atom, not to the bond. Okay, then arrow will be like this only, from a pi bond to adjacent atom, not to the single bond. If it will go to the single bond is there, then if it is going toward that, then that there you can write near the bond arrow will end. But if atom is taking the electron, then arrow will end on the head of atom. Like that way, suppose now from the atom head, it is going to the single bond. That bond is turning to the single bond. Then arrow will start from that electron from the head, because there 2 electrons are there, and arrow will end to the single. Okay, from atom to adjacent bond position. Then this is actually movement of electron. You can show by curved arrow. Movement of single electron is indicated by a single barbed fish hooks. Here you can see. Here is a curved arrow you have written. Then there was this thing, full arrow was there. But if consider in a bond 2 electron is there, then 1 electron suppose it is going to the other atom left side, and other is going to the right side, one electron. Then how will you show this? Movement? Then movement of single electron is indicated by a single barbed fish hooks. Okay, indicated by a single barbed fish hooks. That is the half-headed curved arrow. For example, in transfer of hydroxide ion giving ethanol. Suppose a transfer of hydroxide ion giving ethanol, and in the dissociation of chloromethane, the movement of electron using curved arrow. Now you can write like this. I am telling you, OH bond, hydroxyl ion is there. Then in hydroxyl ion, OH ion is negative, and oxygen has a 3 pair of electron. 3 pair of electron, because 3 pair electron is there, and it is negative, OH 1 minus. Then now 3 pair of electron is there, and suppose this electron pair is giving to the ethyl bromide. Then you can show it by arrow. 1 pair you are giving, then just it will start from that pair of electron, and arrow will be towards the carbon where this electron is going. Okay, means from electron it will start, and arrow will end at the carbon where it is going. And suppose see, this ethyl bromide was there, then carbon and bromine bond was there. Suppose that bond is breaking, then that electron will be taken by bromine. Then again from the bond arrow will start, from middle of the bond arrow will start, and it will come on and it will end, arrow will end on bromine head, on bromine atom. Means it will form CH3OH plus bromide ion. Means now bromine has 4 pair of electron and 1 negative charge. negative charge. Then this way you can show. Another example you can understand. Suppose CH3Cl is there, methyl chloride, CH3Cl. Then CH3Cl, this bond has carbon, chlorine has one pair of electron. Now suppose each carbon is taking one electron and chloride is taking one electron. Homolytic reaction. Homolytic. 1 both are taking. Carbon is taking, CH3 is taking one electron and carbon is taking one electron and bond is breaking. Then from the middle of the bond, this will start, arrow will start, and head will be, arrow will end at the carbon. Two arrow you have to write, one towards carbon and other towards chlorine atom, and it will start from the middle of the bond. Tail will be in the middle and head means arrow will be, one arrow will be towards carbon and other arrow will be on chlorine atom, and it will break CH and it will give CH3 one electron and chloride one electron. Both two radical it will form, methyl radical and chloride radical. Last class I told about the radical also. Now I am telling about the electron displacement effects in covalent bonds. Electron displacement effect in covalent bond. Here what will happen? Just listen carefully. The electron displacement in an organic molecules may take place either in the ground state under the influence of an atom or a subsequent group, or in the presence of an appropriate attacking reagent. Okay. Here the electron displacement of an organic molecule may take place. How? Then either in the ground state under the influence of an atom first, second under the influence of a subsequent group, third in the influence of in the presence of an appropriate attacking reagent. The electron displacement due to the influence of an atom or a subsequent group present in the molecule cause permanent polarization of the bond. Very simple. Suppose methyl chloride is there, then chlorine will attack. Chlorine will attract electron from the methyl group. CH3Cl is there. Then what? Or C2H5 is there and Cl group is there. Then Cl will try to take the electron towards itself. Then chlorine will be negative charge and carbon will be, nearest carbon will be the positive charge. It will develop positive charge. And again, suppose two other carbon is also there behind the first carbon, second carbon is there. Then there also it will create positive charge. But that positive charge will be little less. First carbon will have more positive, next carbon will be less positive, and again suppose third carbon is there, propyl is there, then third carbon again further less. Suppose fourth is there, then again fourth will be further less. Means you can tell first carbon if is showing a delta plus, then second carbon will show delta 2 delta plus, third will show third delta plus, fourth will show fourth delta plus, means it is decreasing. Okay. Then here we want to discuss that things. Inductive effect. Actually this is called inductive effect. Inductive effect is the permanent effect, permanent polarization of the bond. Inductive effect and resonance effects are example of this type of electron displacement. This is actually, this type of electron displacement happens in inductive effect and resonance effect. Both are examples of this type of electron displacement. Temporary electron displacement effects are also seen are seen in the molecules. When a reagent approaches to attack it. Approaching. Okay, when a reagent approaches to attack it, this is a temporary. This type of electron displacement, when a reagent approaching to attack, not attacked, coming to attack, just like a magnet will bring to the some coin, and if it is far, it will try to attract. Okay, like same situation is there. Then this type of electron displacement is called electromeric effect or polarizability effect. Polarizability effect, polarizability effect, what we can tell. In the this here I am going to discuss now inductive effect. Inductive effect. When a covalent bond is formed between atoms of different electronegativity, the electron density is more towards the more electronegative atom of the bond. Such a shift of electron density results in polar covalent bond. Bond polarity leads to the various electronic effects in organic compounds. Here I am giving an example that chloroethane, then two carbons are there and chlorine is attached. Chloroethane, CH3, CH2, Cl, in which then CCl bond, carbon and chloride bond, is a polar covalent bond. It is polarized in such a way that the first carbon 1, gains some positive charge, delta plus, and the chlorine some negative charge. Chlorine gets some negative charge, delta minus. The fractional electronic charge on the two atoms in a polar covalent bonds are denoted by symbol delta, and the shift of electron density is shown by an arrow that points from delta plus to delta minus. Delta plus to delta minus of the polar bond, means it will end at the delta minus. Same already I told you. Now same example just can show by arrow sign. CH3, means ethyl chloride I am talking about. CH3 and CH2, one bond is there, and CH2 is CH2 is attached with the Cl. CH3, CH2, Cl, that is the bond I am talking about. Then bond two carbons, both carbon is attached with each other. Then CH3 and CH2, one bond, and CH2 and Cl, another bond is there. Then Cl will get delta minus charge. Then first carbon will get delta plus charge, and second carbon will get delta plus positive charge. Then direction of electron is from the second carbon to first carbon. You can give the arrow sign that electron is moving from second carbon to first carbon. Arrow sign you can write in the middle, arrow sign. And from CH2, this electron is going to chlorine atom. Then between the carbon and Cl, again in the middle one arrow you can write. This is the direction of movement of electron. This is actually called actually inductive effect, negative inductive effect. In turn, carbon which has developed partial positive charge. Now you can see here. Here carbon 1 got which carbon 1 has got or developed partial positive charge, draws some electron density towards it from the adjacent carbon bond. Then this, because it is now first carbon is lagging some electrons, hence from the neighboring carbon it will try to take some electrons, hence neighboring carbon will become positive, because electron will move from that carbon to the first carbon. Then here carbon 2 also develops some positive charge, where double delta plus symbolizes a relatively smaller positive charge as compared to that on carbon 1. In other words, the polar CCl bond induces polarity in the adjacent bond. Such polarization of sigma bond caused by the polarization of adjacent sigma bond is referred to as inductive effect, because just it is affecting to the nearing carbon also some positive charge they are getting, because electrons are moving from that carbon to the nearest carbon 1, like that, and carbon 1 is giving to the from the carbon 1 electron is moving towards chlorine. This effect is passed on to the subsequent bond also, but the effect decreases rapidly as the number of intervening bonds increases. Here only 2 bond was there, carbon 1 bond, other bond was carbon and Cl. If 3 carbons are there, 4 carbons are there, then as the number of carbon bond will increase, effect will be less and lesser, and becomes vanishingly small after 3 bonds. 3-4 bonds after that it will be very, very less. The inductive effect is related to the ability of substituents to either withdraw or donate electron density to the attached carbon atom. Actually, substituent, what type of substituent is there, that on that this effect depends. Effect depends on the substituent, that how fast it will either it can work in both way. It can give electron also, and substituent group or atom that can give electron also and can take electron also. Then this developed charge depends upon what type of this substituent is there. It can withdraw also and can donate also. Then the inductive effect is related to the ability of substituent in either withdraw or donate electron density to the attached carbon atom. Same way, if they are providing electron, then first carbon will get more electron, second will get less electron, third will get again further less, fourth again further less. Like that way it will decrease, reverse of the first what I have told. Then subsequent these both cases are called inductive effect. Based on this ability, the substituent can be classified as electron withdrawing or electron donating groups. Substituent means groups which are going to attack or attach. Okay, attach. Then they may be called electron withdrawing when they are taking the electron, and electron donating group when they are donating the electron relative to hydrogen. Halogens and many other group such as nitro group, NO2, methyl group, halogen groups, and many other groups including halogen, nitro group, cyano group, carboxy group means nitro groups NO2, cyano CN group, carboxy COOH, ester COOR, aryl oxy means OAR. Also you can tell OC2 O6H5. These are electron withdrawing groups. Always you remember. This group are electron because they want electron. All this group want electron. Chlorine, you know, fluorine, chlorine, bromine, iodine, halogen, they want electron. Okay, that's why it is electron withdrawing group. NO2 also want electron, 2 oxygen attached. Cyano, Cn, nitrogen is attached, electronegative. COOR, 2 oxygen is there. And C double Mr. group, I told you, carboxyl group, COOH, that is also 2 oxygen is there. And this aryl oxy means OAR, means O6C6H5. Here all these are electron withdrawing groups. And just in a reverse way, on the other hand, the alkyl group like methyl, ethyl, these are electron donating group. They can donate the electron. CH3, C2H5, all are the electron donating group. Okay. Now I am stopping only here. Next class again I will continue. Thank you.